Okay, this only took forever. Let me pull up the chat. Oh my goodness. So I'm pulling up the chat now, so have a little patience with me while I get this working. I imagine that the chat will be like, oh my gosh, I'm like 15 minutes late. My wonderful computer has decided to update, right before I stream. So that's the thing that happens sometimes. Hey. So once my chat pulls up, I'll be able to see what you guys are saying. So apologies for the lateness. Thank you for your patience. My technical difficulties and all that. Hopefully you can hear me okay. I'm going to find out here shortly if you can hear me. Hopefully there's no big issue. I'll just check on my phone really quickly. Oh, hey, the chat wants to update. That's nice. Thank you, chat, for wanting to update now. So let me see. Let me make certain I'm live on YouTube. Hopefully I am. I am. I'm live on YouTube. So hello on YouTube. Come on, Restream. Why is it not loading my chat? I don't understand what's going on. Here it goes. Finally. Okay. So I'm live on YouTube. Let me double check because I haven't popped up on here in a few weeks because I was on vacation. And it was, okay, yay. So I'm on Periscope, so that's there. All right. So what we're talking about today, guys, is this awesomeness called subatomic particles. Now, people are like, well, technically it's elementary particles. Well, here's the thing. Subatomic particles are anything that are smaller than an atom. So you can have composite, you can have, let's see. Oh, I have to type in my password. Let's see if that's the right one. Nope. All right. Is this the right one? Been a little while since I've had to type in my password. Yay, I have the chat up now. All right. So I've had people give me a little bit of flack saying that subatomic particles, those are technically elementary particles. Well, you have elementary and you have composite. Fashionably late. Hello. You can hear me fine. Yay, audio is fine. Thank you guys for that. I'm just now catching up on your messages. Yay. Fantastic. So hence the name subatomic. Yes, smaller. So I've been getting people who have been correcting me saying, well, they're elementary particles or they're just called particles. And like, you know what? We're arguing semantics. Anything smaller than an atom is subatomic. Alrighty. So let's talk a little bit about what we're going to do today. What am I talking about? You can't believe you're late. I'm late. I'm late too. So if you're late, don't worry, I am too. So I've been digging around a bit and I have all kinds of resources associated with subatomic particles, and we could talk about this for hours and hours. But if you want to learn more about kind of the cool side of subatomic particles, the CERN website has loads of info on this particular topic. And a lot of the information that I have, I've pulled from there because Hadron Collider, that's what they're all about, are particle physics. So it is a good starting point for particle physics if you are curious about what these little buddies do. And much of my information comes from there, as well as other sites that I actually list at the end of my talks. And I put my slides on my website, ScientistMel.com, under resources. So you can download all of the slides that I have here that I've compiled together with my information, even the things that I say. So whatever I'm talking about here, more than likely, I already have scripted. So a lot of what I do is scripted, and sometimes it's unscripted because I get people to ask me questions. I shouldn't be freezing. If I am freezing, I'm sorry. You might be buffering. I have the highest amount of upload that I can get from here. So, all right. So let's go ahead and talk about what they are, what they do, where do we see them, and what are the mysteries. I freeze momentarily, but it's actually hot where I am right now. Ba-dum-tis. So there's two types of, technically speaking, subatomic particles. We have elementary and we have composite. Hello everyone, thank you for being here. Now, as I mentioned before, the term subatomic particle refers to any particle smaller than an atom. There are customarily these two categories. Now, elementary particles cannot be broken down any further and have no discernible structure. Composite particles are made of two or more elementary particles. Yeah, we don't see them, but we can detect them. So when I say, how do we see them, what I mean is detection. Now, when it comes to subatomic particles, they can be further divided into their purposes. You have things called force carriers, called bosons. I'm not talking about Star Wars, but if we were going to get involved in Star Wars with using the force, we would see them in the form of bosons. Now, these force carriers interact with matter, fermions. Now, particles can be further categorized according to these types of purposes. Now, when we're looking at the particles that work as forces, the forces we're talking about are gravity, electromagnetism, strong or weak forces, and others that work as composing matter. So when we're looking at the ones that compose matter, we're looking at the ones that come together to make nuclei for atoms that then make molecules. These molecules make compounds, and then they all come together to make things like people and rocks and animals and comets and things like that. Oh no, not Star Wars. We use the force to manipulate the matter. You like how that works? Bosons are our midichlorians, and then our matter are our fermions, you know. So we could actually get all the way into it. Yeah, technically midichlorians are force carriers. Bosons, you weren't aware that you had any sons. So it's kind of cool that this actually won the poll, because it's been up for like 3 weeks, you know, 3 times now. So let's talk about the ones that matter. Fermions are the ones that matter. They're made up of elementary particles. So we have this in the form of quarks and leptons. This sounds very Star Trek-ish, doesn't it? Now we've moved from using the force to now matter. So we're talking about the fermions. They are not the enemy. They do kind of sound like an alien, you know, group of individuals that are coming to take over the world. You know, that's the kind of cool thing about particle physics. You're going to find they name these subatomic particles with pretty cool names. I guess particle physicists get bored sometimes. So now we have this little category here. So I'm looking at this. I hope you guys can see. I'm on check, make certain I don't cover up. So yeah, you know, in the little corner I've got over here, it says covers up the yes. You guys know what I'm talking about. So we've got our little categories here for our quarks and our leptons, in case you're wondering. Essentially, we've got 3 different families of matter. So both quarks and leptons contain 6 particles. There are what we call 3 generations of particles, also known as families. Now, the first generation is considered the most stable and lightest of the particles. The second and third generation are heavier and less stable. So we have our electrons, our electron neutrinos, and our up and down quarks are the ones that make the more stable forms of matter. And then the others, the charmed, strange, muon neutrino, muons, top, bottom, tau neutrinos, and taus make the less stable versions of matter. So I have a really cool graphic here that I think you guys might like. This is pretty funny. This made me laugh when I found this. So we saw the technical setup of our quarks and leptons according to families and generations. Now we have these little funny looking things here. So not only do these quarks have cool names, with the bottom also being called the beauty quark, See, physicists, I think sometimes I just wonder if they sit around, they're like, let's call these things really interesting stuff. You know, we're going to call our quarks charms and strange and tops and bottoms and ups and downs and all kinds of weird names like that, but that's kind of neat. They also come in 3 different colors. Now, these colors are not like blue, green, orange, but this is another word for what they use for charges. Also, these 3 types of quarks are also called flavors. And so it's not like vanilla and chocolate and rocky road, but the flavors are up, down, charm, strange, top, and bottom. So those are the flavors of quarks, and the colors are the charges. So hopefully I'm not losing you right now. But at least we know that physicists have a lot of fun doing all of this. You said quarks are gay. I don't know that they're gay. It's just showing a bottom. You know, could be a lady's bottom. Could be anybody's bottom, so it doesn't matter. It's all right. So hopefully you're following me on this. All right. So much like quarks, leptons are categorized similarly. Now the leptons on the bottom have quite a bit of mass and also have charges, while the neutrino versions on the top have little mass and are neutral in charge. So the electrons, muons, and taus all have substantial mass and do actually have a charge, when neutrinos on their counterparts have very little mass and really no charge. They're considered neutral. So you could use the neutron like joke there. You haven't been able to watch for a month or 2. Oh goodness, well I'm so glad you're here. So particles. Now we're going to talk a bit more about particles. So here you guys are, popping up over here on the side with the chat. I like to incorporate the chat like this. So what are we talking about when we're talking about these particles? So when we're looking at ourselves and the observable mass that we see within the universe, the stable matter we have, you, me, animals, compounds, rocks, etc., is made of the first generation, the up-down quarks, electrons, and neutrinos. Now, we certainly don't want our atoms in our bodies to be unstable. That wouldn't make much sense. I mean, why would matter stick together if it's not stable? And so, as it is, it doesn't happen that way. So, yay! We have very stable forms of these particles that make up our individual components, including our atoms and molecules. That's the first generation and the most stable forms of matter. Neutrinos are the things, since they have no charge and since they're small and tiny and have no mass, they kind of pass through us. Like the Force, right? When they talk about that in Star Wars, it passes through us, but it doesn't really connect the universe so much. We're going to talk a bit more about what actually kind of interacts, gives us mass, and is the kind of the connecting of the universe. But so, now that we've talked about the matter, we've talked about the particles that matter, that's really, probably not true. We do very much need our force carriers, known as bosons. They're made of elementary particles, and they have the 4 fundamental forces. So what does that mean? The 4 forces are the strong force, the weak force, the electromagnetic force, and the gravitational force. They have different ranges and strengths, so they have the ability to be infinite or not. They also have the ability to be super freaking strong and not so much. The forces are generated through exchanges of force carrier particles called these bosons. Now, matter particles, this is where they kind of interact with matter. Matter particles transfer energy, very small, discrete amounts, between each other by exchanging these bosons. So I'm going to give you examples here in just a second, but I kind of want to show you what the bosons are. So the bosons are photons, Z and W bosons, gluons, and gravitons. We have yet to find gravitons, but they kind of fit into what we call the standard model for these elementary particles. Gravity is considered the weakest. force but has infinite range. And that's pretty interesting because when we think about gravity, you're like, wow, you have Jupiter and it has all of this gravity, and if we went there, we'd be crushed. So when we're able to sit here and we think about gravity, overall, it's considered the weakest force. But it does have infinite range. So it can go on and on and on and on and on, but it's still considered the weakest out of all of them. The electromagnetic force, like gravity, has infinite range, but is ridiculously stronger than gravity. So what do we mean by electromagnetism? So we look at photons. When we're talking about the visible spectrum or the infrared spectrum, or we're talking about X-rays, or we're talking about cosmic radiation, UV radiation, these are all this is all part of the electromagnetic force. So, for perspective, we know UV radiation causes cancer. We're going to get into the Higgs boson. I'm going to get into that in a bit. But we have to kind of understand what these other particles do before we can even jump on the Higgs. All right? So we're looking at the photons, and Einstein was the person who actually confirmed photons. And photons do have some kind of mass because gravity affects it. And we know that. That's how he was able to show that light bends due to gravity. That was the lunar eclipse experiment that he did. But we also know large amounts of photons, when we're talking about high frequencies getting blasted at you, can actually destroy the bonds between atoms and compounds. This is why you don't want to get blasted with cosmic radiation. So we know that photons in that regard have an extremely strong amount of force compared to gravity. Because you get blasted with high frequencies of photons, that's going to affect you a lot more than just like the gravity on our Earth. The gravy boson is the tastiest. So when we're talking about the weak and strong forces, so we're looking at the W boson, the Z boson, and the gluon. Now, these particular weak and strong forces only really work over a very short range and really only have a substantial effect at the subatomic level. But they're still considered much stronger than gravity because of what they do. Gravity is still considered the weakest. Now, the strong force that's generated by gluons is the strongest force of all four interactions. So, cause thymine dimers. This is Drag. Hello, Drag. We're talking about subatomic particles, guys. This is fun. I got to dig around and find all kinds of fun stuff today, so that's cool. I'm glad you guys got this. All right, so what I want to talk about a bit is something called the Standard Model. So this is what physicists have currently worked out in regard to how these particular particles interact together and what they do. And right now it explains well how electromagnetic strong and weak forces and all their carrier particles interact with matter. However, gravity is a bit of a conundrum because it is not part really of the Standard Model. It does not seamlessly fit into the model as well as the others and then the more easily observed particles do because we haven't found the graviton yet. So we can't completely throw gravity in there. Now the quantum theory, that's what we consider the micro world. That's what that theory kind of discusses those particular particles and how they interact with each other. And the general theory of relativity, what we see in the macro world, that's the Einstein stuff, do not play so nicely together in a single framework. They are not yet mathematically compatible in the Standard Model. But the good news, what's the good news here? Since particles are so tiny, the effect of gravity is so ridiculously weak that it's considered negligible. Gravity only matters when matter is in bulk. So for example, our bodies, animals, planets, minerals, comets, that's when gravity shows its strength. The Standard Model overall works well enough regardless of the exclusion of gravity. Is CERN looking for gravitons? I'm not entirely certain, but I would hope that they would be able to do that. Particle physics isn't totally like my field. I do have an understanding about it, and I did actually have to take physics where it was involving particles when I was getting my first undergrad degree. But when you're implementing fields around a particular thing, that's where you kind of see these particles and how they behave, like the presence or absence of magnetism. I'm going to talk a bit about the Higgs field because that's where the Higgs boson kind of matters. But hopefully CERN is looking for the graviton. Everything counts in large amounts. Isn't that a Depeche Mode song? Okay, so I have here, I'm covering this graphic now, so I'm going to shrink myself. Whoop, there we go. Now you guys can see that a bit better. Big and small, big and small. The shadow government implanted nanotech in my system and it's been disruptive. Okay, Bruce. All right, so just to kind of recap a little bit. So I've shown you kind of fun little pictures about the subatomic particles. So these are our elementary particles in the standard model. And what we have here in this particular image is the mass listed at the top, the charge, and then the spin. The spin has to do with the direction that it's moving, this way or the other way, right? The charge has to deal with the particular charge that these particular particles have. And then the mass, well, that's, how much mass does it have? Its size. So just to kind of recap a bit, all quarks have mass and an electric charge of either positive 2/3 or negative 1/3. So the up quarks have a positive 2/3 charge and the down quarks have a negative 1/3 charge. Now, for example, I just went through that. So quarks also have different types of charges. This is what we call colors. So the charges are colors and the types of quarks are flavors. So if you go to an ice cream store, you can say, I would like an up-down double scoop, please. You know much, maybe too much. I'm so glad you like these tables. All right, so the quarks are in groups of 2 or 3. They're not by themselves, so they clump together in groups of 2 or 3. Now, if you combine their individual charges together, you get a final charge. For instance, when we're talking about building them together and forming matter, we look at protons. A proton is made up of 2 quarks, 2 up quarks, and 1 down quark. So when you add those charges together, you get a total of 1 positive charge. That's a proton. All right, so that's kind of how we're starting out building up the nucleus of an atom. This is the beginning of that. Leptons have an electric charge of either -1 or 0. Electrons have a charge of -1. So leptons have mass, although the mass of electrons is extremely small. There are the 4 types of bosons that I mentioned before. The force-carrying particles, you remember, those force-carrying particles are exchanged between matter, right? So we've got release of photons. So you can have releases of photons. You can have releasing of Z and W bosons. And so then we also have the gravity of the gravitons that haven't been discovered yet, right? And so the bosons have an electric charge of +1, -1, or 0, and they may or may not have some mass. And somebody said before, what about the Higgs? Here's the thing that makes the Higgs so incredibly interesting. Here's the things that makes the Higgs so interesting. So we understand that these particles, the force-carrying particles are the particles that are exchanged between matter, but we're like, how does it get the mass though? That's where the Higgs boson plays a role. So let's talk about the Higgs boson. Now this image comes to us from CERN. This is the thing that fills in the weak and the electromagnetic interactions. So we need to know how the electromagnetic and weak interactions work with one another. And we also need something that gives particles their mass. So that's what where the Higgs boson plays a role. Hello, everyone. So what are we talking about? Some people are like, I've heard the Higgs boson. I know they were talking about Higgs boson in the news, and they're like, oh, it's the God particle. Oh, it's the Higgs boson. Oh, the Big Bang. So all these words are getting thrown around, and people are like, what the heck is this? I do not understand why this is so important. All right, so on the CERN website, on July 4th, 2012, ATLAS and CMS experiments at CERN's Large Hadron Collider. I know you guys have a hadron for science. That was my cheeky joke of the day. I will show myself out. Thank you very much. They announced on July 4th, 2012, so that was like 6 years ago, and on the 4th of July, that they observed this new particle with a mass at about 126 giga-electron volts. It is consistent with the Higgs boson, fitting the standard model. Now, we need more experiments to confirm that if it is indeed this particle. If you're not certain what the Higgs boson is, it's proposed within the standard model is the simplest manifestation of what they call the Brout-Englert-Higgs mechanism. And you're like, what the heck is that? Well, this particular mechanism was proposed as to giving mass to the W and Z bosons when interacting with what we call the Higgs field. What's the Higgs field? I will tell you. At the Big Bang, the universe had a 0 Higgs field. Now, as the universe cooled, the field started to grow. Now, as the particles interacted with this Higgs field, they grew in mass. But they're like, how did they get that mass? This is where the Higgs boson comes into play. It is the manifestation of the Higgs field contributing mass to these W and Z bosons, as well as the other particles that interact with it in order to give it mass. On October 8th, 2013, the Nobel Prize in Physics was awarded jointly to Francois Englert and Peter Higgs for the theoretical discovery of a mechanism that contributes to our understanding of the origin of mass of subatomic particles, and which recently was confirmed through the discovery of the predicted fundamental particle by the ATLAS and CMS experiments of CERN's Large Hadron Collider. So we are nearly there for rounding out our understanding, but we need more data from experiments to be able to fully show how the Higgs field and subatomic particles interact to grow in mass. Oh dear, did I say something silly? I tell a lot of really stupid jokes sometimes, but you know, hey, that's okay. Hello everyone. So kind of just to sum up everything, we have talked about subatomic particles. What are they? What do they do? Where do we see them? Where are the mysteries involved? So this is all kind of the fun stuff that we've kind of just been tossing around here. The CERN website, as I mentioned before, if you haven't checked out the CERN website, it does have a load of information, including videos that talk a bit about subatomic particles. Now, it's not heavily technical, and so the person that actually built this site, the person that worked on writing it, did kind of bring it down to a very accessible level. So don't be intimidated by the CERN website. Go check it out and see the different stuff that they have. Silly jokes make hard topics better. I agree. I do tell a lot of silly jokes. So if you want to recap, if you missed the live stream, fear not. I leave my videos up forever. They're there for you to use and enjoy at any time. And if you have questions, you can hit me up here in the comments. You can also find me on Twitter, and I'll talk about where else you can go. So here are and I don't expect you to be able to read all these. There's no way you'd be able to read all these, so fear not. I checked out about 13 different sites this morning. I actually spend my time every Saturday morning compiling the shows because it's kind of a short period of time between the poll finishes and what it is that I'm talking about. It's about 6 a.m. every morning I get up and I build the show. And then it's like always, it cuts it close almost every single time for me to go live. But I will put all of these on my website, ScientistMel.com. You can download the slides from there. If you don't have Microsoft Office, you can try OpenOffice.org. It's free. You can download it, and you are able to open up all of the Microsoft suite on there. So you can check that out. I used that all through my undergrad years before they allowed us access to Microsoft Word. I'm so glad you enjoyed this. So that's subatomic particles. I didn't change the date on this slide. I did on the first one, but not this one apparently. So I want to take a moment to thank all of my patrons for being there for me. And if you're one of my patrons, you get access to an exclusive show called Science Sunday School, streaming every Sunday at 3 p.m. So Tony, James, Lauren, Jen, Carl, Melanie, Patrick, Daniel, Stephen, Paula, Tim, Carrie, Cersei, Keith, Duke, Andy, Zachary, Tony, Bo, Stephen, Sarah, Graham, Dragnot, Godless Iowan, Jennifer, Corey, and Heavy. I'm going to organize this a bit better because all of you guys have different titles associated with my Patreon. So if you want to join, it starts at $1 a month. They help me keep the lights on. I've been able to get stuff. I'm going to start working with a green screen soon. And also I have my Science Sunday School just for my patrons where we talk about the latest and greatest in scientific discovery. And soon I'm developing a show called Masterclass where we'll actually dive into much harder science. While this particular show talks about the basics, making all kinds of science accessible, if you want something more challenging, I'm going to have a show called Masterclass where you'll be able to dive in and hear about some of the harder topics. So that'll be really cool. Where can you find me? Everywhere on the internet. ScientistMel.com, Patreon, Periscope, YouTube. I'm on Facebook and Twitch. I didn't get this up on Facebook yet, but I'll upload it later, even though it won't be live. People will be able to watch it on Facebook later. Thank you guys so much for being here. If you got any questions, I got like 14 more minutes. Let's have a chat. Subatomic particles. This has been pretty freaking interesting about that. And thank you for your patience earlier because I started a bit late. My computer decided that I needed to update right before I streamed. And I'm like, thank you, Microsoft. Having me update like this. It's freaking insane. So it's nuts. Let's see. I've appeared on a few other shows recently. So I'll be on the Non Sequitur show, I believe, on August 3rd. So you can check that out. And then I've also been on the Godless Iowan show. He recently had me on there talking about the scientific method. So you can check him out. I'm hoping I still have a few other shows on YouTube.com. And all of my shows, if you haven't subscribed, please do. And then if you're like, oh, wow, there's so many videos here on my YouTube channel, if you get freaked out, I put everything together into playlists. Oh, that was easier to understand. I'm so glad that was easier to understand than the books you read. What I find that's really cool about this, because I don't have, particle physics isn't like my field, but I understand enough of it to where I'm like, I know what the scary stuff looks like. So it's just like, virtual particles. I haven't gotten into virtual particles. So I didn't get into that. I got into like the elementary particles and then the composite particles. And then I talked about the Higgs boson. And I also talked about what these particles do, how they interact, how they fit the standard model, how gravity doesn't quite fit in the standard model. We still haven't found the graviton yet. So there's still lots of mysteries and questions we need to answer in regards to particle physics and subatomic particles. But they have really fun names, so we know at least physicists have a fun sense of humor. It's okay. So we have flavors and colors, Colors are charges. Flavors are the types of quarks. So, you can ask for an up, down, bottom, 3-scoop sundae, of various colors, charges of quarks. So I just, at least that was just comical to me. You know, when I was first learning about subatomic particles, I'm like, you know, physicists have a pretty interesting sense of humor. Yes, I was late too. I was late to my own show because technology is rude sometimes. Very rude. It's extremely rude. So, but yes, you'd like to learn about virtual particles too. Oh, that could be a subject for another video. So, you know, toss that in. If you have ideas for my show, I do, you know, all of my shows are viewer generated in topics. It's a rare day that I just have a show about a thing. Usually my shows are all viewer generated for the science of. And then I have shorts, ScientistMel shorts, where it's a shorter version of these shows here. So if you don't like the long live streams, that's okay. That's okay. You can go and find my ScientistMel shorts and watch the shortened version. You'd love to learn more about zoology. Oh goodness. Then, you know, an interesting shows to watch if you like lots of stuff about animals. I would recommend P.Z. Myers. He talks a lot about evolutionary biology, especially since his first degree was in zoology and animal anatomy. If I hadn't been late, you would have missed the whole thing. Oh, and if you're not on my Discord, you should totally hop on my Discord. And if you're a Patreon contributor, you get your own little Discord chat room, and you get your own Discord benefits too. If I drop a few pounds, will I lose bosons? Probably. You know, you'll be losing bosons. Yeah, you probably will. I mean, let's see, probably WZ bosons. I don't know if you'll be losing photons. Those are light, so I mean, we do have, you know, we do release stuff in the form of heat, and usually in a combustion type of situation, you might lose some photons, you know. So usually that's why we see it. That's why fire, you know, releases photons in the form of light. So it's heat and combustion. So we lose light and, you know, heat. So that's pretty cool. Plug your Twitter for, oh yes, hashtag. So if you don't know, my Twitter gets really, really full. And then one of the cool things I have about Twitter is I can use TweetDeck, and so I can schedule tweets and stuff, which is neat. So I can always schedule tweets and try to interact when I can otherwise. But if you use my hashtag, HeyScientistMel, that's exclusively for people who want to communicate with me. Because my my mentions, they fill, and I don't always get them. And then like on a Saturday, I'll see somebody like heart a tweet from a week ago that I didn't even know somebody had said to me. So it's like, use my hashtag, because I can always click on that and they all show up. You know, that doesn't get overloaded so much. Aaron Raw, yeah, he is really good at explaining evolution as well. If you're looking more for like animal science, Jackson Weed is pretty good with animal science, as is P.Z. Myers. They're really good about discussing like the various types of animal science. You plan on doing a playlist called Science for the Newly Deconverted. And may have to have Mel and Jackson Weed on. Sure. You know, I don't mind coming on people's channels talking about science. I do that often, so you'll see me appear in other people's shows talking about stuff like that. So let me see. I'm scrolling back to see if I can find other questions. You love the laugh. I like to laugh. And I do, you know, I find I feel good when I'm laughing. So I'm scrolling back a bit, see if I can find any more questions. All right, and you can join my Discord. You know, it's weird. I get the notifications on my desktop, but for whatever reason, Discord app doesn't like to give me my notifications on my phone, so I try to check it as much as possible. All right, so I think I've got all the questions that people have had. Scrolling all the way down. All right, okay. So, also, I recently wrote an article on ScientistMel.com about alternative medicine and cancer, and that's kind of caused a bit of a stir on my Twitter with people going, this is a very biased article, and people are like, thank you for writing this. So I'm getting a lot of mixed reviews, so it'd be pretty interesting to kind of get your perspective. And if you read something that I've written on my website and you want to talk about it, you can comment there. You can shoot me an email. You can contact me through my website and email, and you can kind of bring it up on Twitter on my hashtag. there's more and more studies that are being done to look at people who choose alternative medicine over conventional medicine. And this particular piece that I wrote has to do with two different studies that have come out about the outcomes associated with people who choose alternative medicine over conventional medicine and cancer. And so the thing is, you have a 2 to 5-fold increased risk of death if you choose alternative medicine over over alternative medicine over conventional medicine if you have a diagnosis of cancer. And they looked at a lot of different cancers. There are about almost 2 million people involved in that particular meta-analysis type of study where they examined the outcomes for people who used one or the other. So do check it out. And that would be pretty neat if you wanted to give me a bit of feedback on that. And if you like those types of articles, I'm happy to write more. And then my Science Sunday School talks a bit more on Sundays for my patrons about the newest stuff that's come out in science. So that may be made accessible to the general population down the road. But right now that's a show exclusively just for my patrons. And I have a new person that's going to join me on my audio podcast. I haven't updated episodes for that in a while because it's been full on hectic. But I have a new person that's joining my audio podcast. So that's going to be really, really cool. We're going to start recording on Monday. So that will be awesome. And she's picking out topics and we're going to break them down and we're going to talk about them on my Hey ScientistMel audio podcast. Hashtag Hey ScientistMel is the title. Steve Jobs chose alternative medicine to treat his cancer, which is really strange. Redacted, follow me on Twitter. All right, sweet. So yeah, if you haven't subscribed, subscribe. I'm still trying to get up to 4,000 hours of views on YouTube. So I think I'm about 1,300 to 1,400 hours away from getting that, because then I can start monetizing and then I can get super chat and then people can interact with me a bit more and more features are available. Not quite there yet. So yeah, so that's something that I'd appreciate if you could just maybe have a ScientistMel marathon at your house one day. Tell me about it. Tell me about it. And I'll talk to you all day about it. So, yeah, we all know how it turned out with Steve Jobs. Yeah. But if there's a topic you want me to talk about, let me know. Because this show is for you guys. This show is to help break down science concepts that, you want to learn about. And so that way I can make it to you in nice little accessible packages for your entertainment and enjoyment. And I want you to learn stuff and I want you to enjoy it and feel excited when you learn something new, because that's me every time. Every time I learn something new, I'm like, oh my God, this is so cool. This is so awesome. So I want to share that with you and give it to you. So, oh goodness, you're telling each other to splash yourself with 200 proof alcohol after shaving. Oh my gosh. Can you get 200 proof? I think it's like I guess that's 100% alcohol. So that is 200 proof. Why in the world would you want to do that, man? It burns us. If you do that, you have to do that in the Smeagol voice. It burns us. It does. You have to do that in the Smeagol voice. When am I going to? I've already talked about subatomic particles. The show is over. It's over. Here, you missed it. Here, let me help you out. I'll go back and show you what we covered. That was so this is what all I covered today. But if you missed it, that's okay. You can go back and watch. I talked about all the things. Yeah, a little bit of, hold on. Here we go. Subatomic particles there. We talked about the Higgs boson. All of that. That's okay. I was late too. So it's okay. It's okay if you're late. You can go back and watch it again. It's not a terribly long episode, so that's all right. It's about 40. We're at 45 minutes now. But if you can, I'll show you where you can find me again. Let me go back to where you can find me. last little opportunity to find me. Here we go. See, I write a lot of this stuff, man. So just to kind of give you an idea about what I do. It's okay if you missed it. You can go back and watch it again. Please do, because I'm really close. I'm getting closer to my 4,000 hours on YouTube, and it's very helpful for me if you go back and just have a binge marathon of ScientistMel stuff. This is where you can find me. And as I said before, Patreon, they get their own show called Science Sunday School. It's a 15, 20-minute show, and then I now have a new person for me on my audio podcast who's contributing to that content creator. So she's really awesome, and you guys will get to learn more about her and all of that. So yay! What about chaos theory and predicting weather cycles? You know what? How about I add that to the list of topics, and we'll see if that wins. Neutrinos. Are they knockoffs of Totino's pizza rolls? Oh my goodness. Well, you guys have been awesome. Like, share, subscribe. All of that fun stuff that you can do. How do they count bosons a bosometer? You know, the neutrino detector. That's something that I didn't bring up. You know, for the neutrino detector, I believe it's in Japan. It's a huge compartment that's filled with, I believe, purified distilled water. And you can sit there, and every time neutrinos pass through, it lights up the room. If you haven't, if you'd like to kind of check that out, Cosmos, with the rebooted version with Neil deGrasse Tyson, he actually is inside the neutrino detector, and you can watch as it lights up when it detects neutrinos. It's awesome. I didn't contact Netflix. I still need to do that. So if you... I would love to have my own Netflix show. That would be really cool, wouldn't it? Talking science with ScientistMel, that'd be kind of neat. So that would be kind of neat to do. They have, I don't know how to go about that. I'm not very good with that aspect of things. So I suppose it'd be neat to be able to contact somebody and kind of see how we can go about making that happen. That'd be cool. Well, you watched that episode. That was a cool episode, huh? Well, I'm gonna hop off here because it's 11 a.m. now. What are my thoughts on Tesla? Not the car, by the way. I did a whole show. I also have a show called Spirited Science, and I'll plug that really quickly. If you go on my YouTube channel and click playlist, I did an episode of Spirited Science on Tesla where we made Tesla cocktails, and we talked about Tesla, the things that he discovered, the things that he talked about. I've also done an episode on Darwin, and I've done an episode on Turing. I'm still trying to get the people together for my Katherine Johnson talk, but check it out, and you can watch it. It's a lot of fun. I'm so glad you guys had fun here. I didn't even do my intro. That's how behind I was. So I will end with my intro. Thank you for being here. This is always awesome, and I'm super glad I get to share science with you. I will see you guys. If you're on Patreon, I'll see you on Sunday. If not, I will see you guys next weekend for the next topic. Have a great Saturday.